All right, so in 1.5, we talked about the measure of the angle. Okay, we did the angle addition postulate and the protractor postulate. So for 1, 2, and 3, it just said classify each as acute, obtuse, right, or straight. 1 would be what? Right. 2 would be? Good. 3 would be? Easy stuff, right? 4 says if the measure of DEG is 84, so on this drawing here, DEG would be the whole angle. If that's 84 degrees, find the measure of FEG. How do I do it? Santi.
Oh, so basically you add 3x plus 10 and x minus 6 and set it equal to 84.
Good. 3x plus 10 plus x minus 6 equals 84.
Then you combine your like terms.
4x plus 4.
You would end up with 20 after doing all the work.
Okay, and then that's your x, right? Not the answer.
Then you plug in the x to whatever they're asking you for. So you plug it into x minus 6.
Good. FEG is the x minus 6, so I would do 20 minus 6, and I get 14. Good job. Okay, 5 says if XY bisects ZXW. So I've got an angle called ZXW, and I've got a bisector that's XY. And what did we say a bisector does? Splits it into two congruent parts. It says that the measure of angle ZXY, which would be this top one, is 36. And it wants you to find the measure of ZXW. How do I get it? Just double it or double it or 36 plus 30. Wait, that's just kidding. I just said doing things at the same time. 36 times 2, which is 72. Okay, and again, pay attention to the letters. Like if it had asked for YXW, it would have been 36 because it asked, God bless you, for the big one, it's at 72. And that is like, you know that because of the definition of an angle bisector and angle addition postulate. You used both. All right, homework. God bless you.
Bless you.
So 4 and 6 both said to write the names for the angle, write 3 names for the angle. Remember, you can use the vertex because it's not shared, and then the letters in either order. So for 4, it could be G, F, G, H, or H, G, F. For 6, they even added the angle number. So you could have done angle 8, angle R, and angle QRS or SRQ, as long as the R's in the middle. For number 8, it said same thing, name 3 different angles. So you could call it angle JGC or CJG. That's the top one. CJF works, or FJC, that's the blue one. And then the big one is GJF or FJG. So this time it said different angles, which means I can't use like both GJC and CJG. That is the same angle, just a different name. So be careful with stuff like that. Number 10, 65 acute. Number 12, 25 acute.
So for 12, could you just count how much times it goes?
Sure. Yeah.
But how would you actually get it?
So for 12, it says EOD, right? EOD is the angle that's here. Mm-hmm. You can do this angle, which is in here, 65, minus this angle, which is 40.
Wait, when do you use the top numbers and the bottom numbers?
When it's obtuse, you use the top number. When it's acute, you use the bottom number. If it looks like it's bigger than 90.
Bigger than 90.
Yeah. So like COB is obtuse. I would grab the 150 instead of the 30.
I agree.
Okay, 18. Identify the angles congruent to EAD. That would be ADB and CBD. The one with 2 arcs. There were 2 with 2 arcs. Number 20 would be 112. Yeah. Good? Yeah. 22, you're finding the big angles, so we're adding those together, which is 108. 26 is X, Y, W is 32, and W, Y, Z is 85. So to add them up, add those two expressions together, and set them equal to 117. So those kind of questions, like especially this question, I'm looking for work on that. You literally have to set up your equation. 6x plus 44 plus negative 10x plus 65 equals 117. Then you're going to combine your like terms. Negative 4x plus 109 equals 117. And then you're going to subtract the 109. Like all this work needs to be shown. And then divide to the right. So that when there are questions that require work, which I would say like 26 requires work, 28 requires work, I'm definitely looking for it. And if you don't have it, you're going to get docked. So don't hurt yourself with your grades, okay? I said for questions like that, like 26 and 28, where you're setting up an equation solving, I'm definitely looking for work.
Okay.
So you need to make sure you're showing it.
Oh, wait. I know I don't have work for 28.
Why?
Cause like,
Wow.
wait. Let me see.
Wait, so
'Cause
if you're
it's
just like a
rated
genius and you don't do any work.
You have to prove to me that you're a genius by showing the work, right?
It's like 180.
This, yeah, but you have 14x plus 70 plus 20x plus 8 equals 180. If you are doing in your head, you have to stop and you have to show the work. So this would be 34x plus 78 equals 180. 34x equals 102. Divide by 34. Divide by 34. And then you have to plug it back in, right? So there's a lot of work there that I'm looking for. And if you don't have it, you're going to lose the points. A lot of questions don't require a lot of work. They're naming stuff, no work. But stuff where you have expressions and you're setting them equal to each other or you're setting up an equation, you need to make sure you're showing your work. All right, so 30 FEH is 51 degrees and DEH is 39 degrees. Yeah.
I got 41 and 26.
Did you add them together and set them equal to 90?
Yeah.
So you got 23x plus 21 equals 90. Subtract the 21. 23x equals 69. Divide by 23. X is 3.
Oh my gosh. I put X is 2.
Okay. And then plug it back in. I mean, better to make a mistake like that on the homework than on a quiz or a test, right?
I think I did them right, but I don't know.
All right, 34. Like, if you don't know, how am I supposed to know? 34. Oh, it's so blurry. 34 is 71 for POS. I mean, PQS, sorry. And then 142 for PQR. 36, this is 59.5, and this is 59.5.
Yeah.
I know, I'm going to read them out loud, but I know it's blurry. This one's 71, and this one's 142. For 38, A, B, D equals 24. C, B, D equals 24. A, B, C equals 48. Those would also require work because you're setting them equal to each other, solving for x, and then plugging it back in. A, B, D equals 67 for 40. C, B, D equals 67. And A, B, C equals 134.
I didn't do these.
Well, that was an interesting move.
Mark, what would you not do?
I don't know. I didn't see them.
Think you slick?
42 is 75 degrees. 44A is 112 degrees. B is 56 degrees. C is 56 degrees. And D is 56 degrees. Yeah.
You do 34.
Mm-hmm. So 34. This is your angle P, Q, R, S. It says in the directions QS bisects PQR. So this one is congruent to this one. The directions on 34 say that RQ RQS equals 71 degrees. So RQS is the bottom angle here. If this is 71 degrees, this is also 71 degrees, and the big one would be 142.
I honestly do not know what I did.
Okay.
I probably assumed that they weren't.
Maybe you labeled 71 as the big one?
No, I got completely different answers.
Maybe it's that new math that you're trying out.
How do you do 38?
38, it says that BD bisects ABC, so these are congruent, which means the 3x plus 6 is going to be equal to the 7x minus 18. So 3x plus 6 equals 7x minus 18, and then I subtract the 3x. 6 equals 4x minus 18. I add the 18. 24 equals 4x, and I divide both sides by 4. X is 6, but directions say find ABD. So ABD is the top one. I have to take that and plug the 6 in. And then find CBD, which would be the same because they're both the same angle, and ABC would be double that.
Yeah. That sounds easy.
Any other questions? All right, 1-6, last section in the chapter, which is describing angle pair relationships. So now we're going to learn about a couple of special angles, okay, and what it means if they are those angles. The first two, hopefully we've heard before, complementary and supplementary. Two angles whose measures have the sum of 90 degrees are called complementary. And two angles whose sum is 180 degrees are called supplementary. If you tend to confuse these, remember C comes before S and 90 comes before 180, okay? And it's only two angles. Like I can't say three angles are supplementary if they add up to 180. They can still add up to 180, but they're not supplementary because it's only two. Adjacent angles are two angles that share a common vertex and side but have no common interior points. So if you look under both complementary and supplementary, there are examples of adjacent and non-adjacent. So adjacent would be like angle 1 and angle 2. They are next to each other and they share a side, but they don't overlap. Same thing on the supplementary side. Angle 5 and angle 6 would be next to each other, but do not overlap, so those are adjacent. The others in each section are not adjacent. They can still be complementary and supplementary, but they're not adjacent because they're not next to each other. You'll also see it where you have something that like overlaps. So let's say I have this, and I have two. So angle ABD, ABD is not adjacent to EBC because they overlap.
Non-adjacent or
Not adjacent. You could say either. So those can't be because they overlap, okay? Adjacent would be like an angle 1 and an angle 2. This one.
Why isn't these playing?
Okay, so again, 1 and 2 would be adjacent. 3 and 1 would be adjacent. 3 and 2 are not adjacent because they don't share the same side, okay? All right, example 1 says use the figure to name a pair of A complementary angles, B supplementary angles, and C adjacent angles. Give me a pair of complementary angles. Shanti.
Wait, do they have to add up? To
Yep.
90?
Yep. Jonathan.
Oh yeah, I got it.
Okay, go ahead.
RST and
RST and
CAB.
good. And the order of the letters doesn't matter. Like those could be switched. T, S, R, and B, A, C, as long as the S and the A are in the middle. So if I add the 32 and the 58, they add up to 90 degrees. That's what makes them complementary. How about supplementary? Jonathan.
RST and CAD.
Good. RST and CAD, the 58 and the 122 would add up to 180. And adjacent angles? Sophia?
BAC
BAC.
and CAD.
Good. CAD.
But just because they're adjacent doesn't mean we have to add up to anything?
Correct. Everybody good so far? All right, this one says, when viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find the measure of BCE and ECD. So if this here is the x plus 2, and this angle here is the 4x plus 8, how do I solve this question, Sophia?
4x plus 8 plus x plus 2 equals 180.
Good. And then I'm going to combine my like terms. 5x plus 10 equals 180. Subtract the 10. 5x would equal 170. Divide by 5. All right, 170 divided by 5 is 34. And then I'm not solving for x, I'm solving for the actual angles. So for BCE, which is the first one, I'm going to take and plug back in 34. 136 plus 8, which is 144. That's angle BCE. And then what's one way to find angle ECD, because there's two? What's probably the easiest way? Kala.
Subtract.
Okay, good. Subtract it from 180. So I can do 180 minus 144, which is 36. If I have extra time, you can also plug it in to check. 34 plus 2.
Why can't it be like?
What?
Why wouldn't it be like? Why should I?
Like, why would you pick that one over plugging in?
Yeah.
Just because it could be faster. This time you're only adding 2, so it's not that big a deal. But if you had to multiply and then add, it's an extra step. Yeah. And then again, I would check it. Make sure the 144 plus the 36 add up to 180 if you're going to do it that way. Questions on that one? All right. Next two vocab terms for angles are called linear pair and vertical angles. A linear pair are two adjacent angles this time, so they have to be next to each other, when the non-common sides are opposite rays, which basically just means the outsides form a line. They always form supplementary angles, which means they always add up to what? 180. So this diagram on the left is an example of a linear pair. Two angles whose non-common side, right? The common side is the one that's in between them. So this is the common side. Their non-common sides form opposite rays or they form a line, okay? That's the same thing. Vertical angles are two angles whose sides form two pairs of opposite rays. They make an X, okay? So in the diagram that's there, 4 and 5 are vertical angles. Each side of 4, so if I draw out 4 and I extend the sides of 4, they then form 5. So those are vertical angles. And 3 and 6 are vertical angles. So they form an X. It could be a skinny X or a wide X, but they form an X. The sides of one extend to form the sides of the other. Linear pair and vertical angles are probably the two most common things to see on standardized tests like years down the road. They assume that it's like one of the most important pairings of angles, okay? We're going to learn about a lot more angles, but a linear pair and a vertical angle is like something that you'll see on an SAT or an ACT, some sort of application of it, okay? Because they're super important. Good so far? Yeah? All right. Two angles form a linear pair. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. Sophia.
So, wait, can I take it?
Just tell me how you get to it, but yes.
Okay, so you make like a straight line which equals 180,
Okay.
and then you divide 180 by 5.
Well, but one is 5 times the other, so you still have the other one. So if one angle, let's say this is the one I don't know, right? I don't know anything about either angle, but let's say that first angle is x. I don't know anything about it. What's the other angle?
X. 180 minus X.
Nope. 5 times x, right?
Okay.
It is also 180 minus x, but that's not going to get us what we need to. So the measure of one angle is 5 times the measure of the other. The other is my x. That's what I don't know, okay? But the first one is 5 times that, which means it's 5x. Because they're a linear pair, x plus 5x equals what? 180. So then 6x, you're not wrong. 5x plus 5x does equal 6x. 6x equals 180, and then divide both sides by 6. X is 30, which means the smaller angle is 30. And the other one is what? Good. 5 times 30 or 150. So here's the issue with Santi. Your logic is right, but if I did one angle is x and the other one is 180 minus x, and I add these together and set it equal to 180, what happens?
C equals 0.
It's 180 equals 180 or 0 equals 0, which is all angles, right?
Yes.
It's okay. It's a. All right, example 4. The measure of an angle is twice the measure of its complement. Find the measure of each angle. These are great standardized test questions, okay? So what's the relationship between an angle and its complement?
Measure angle is twice the
They add up to 90. So the measure of an angle, which is my x, that's what I don't know. So the measure of the angle is x. The measure of its complement is 90 minus x. That's the replacement of complement. But it's saying this angle is twice that angle, which means I'm going to get, how do I show twice that? Relationship. This is twice this. So x equals 2 times 90 minus x. The other way will always work itself out like the first way. So this is x equals 180 minus 2x. Then I add the 2x. 3x equals 180. Divide by 3. And x is 60. So if an angle is 60 degrees, what's its complement?
30.
30 degrees is 60 twice 30. Yes, that's how you can check it, okay? Jonathan.
I just did 2x plus x equals 90.
That's fine. It works the same.
So you went to 60 or 30?
It's both because it said find the measure of each angle. Okay, you could have also said an angle, so an angle plus its complement, 90 minus x, or plus twice its complement, right? What did you just say, Jonathan? What did you set up? 2x plus x equals 90. That's fine too. An angle plus twice, or an angle plus twice that angle would equal 90. That works too. So what would have happened? Sorry, let me go back. What would have happened if that had said supplement?
Do 180.
Or you do 180 instead of 90. That's it. Okay, so the supplement would be 180 minus x, or you would say 2x plus x equals 180. Either way. All right. So this one just says there are some things you can't conclude from a diagram, and there's some things you can, and some things you cannot. For example, here are some things that you can conclude from a diagram. Points are coplanar, so if there are any 3 non-collinear points would be coplanar. Points A, B, and C are collinear, and B is between A and C. It doesn't say it's halfway between, it just says it's between it. All 3 of those line segments and rays intersect at point B, so this this, and this all intersect at point B. Angle B or DBE and EBC are adjacent. That you can see from that diagram. And ABC is a straight angle. That you can see from that diagram, which means it's 180 degrees. That's the only time you can give a value to a diagram that doesn't give you any kind of angle measurement. And point E lies in the interior of DBC. So E, like all of those things you can get from that picture. What you cannot conclude is that it is a right angle from this picture just because it looks like it. So you would have to see the right angle mark in order to know that it's a right angle. You cannot conclude that AB and BC are congruent just because they look like they're the same length. And you cannot conclude that angle DBE and EBC are congruent just because they look like they're congruent. So unless you physically saw all of these marks, you cannot make those decisions. Something that just appears to be right cannot be 90 degrees. You would have to have the perpendicular mark, or it'd have to say somewhere that it's a right angle.
Will it always have the marks?
If it wants you to know that it's a right angle, it will have the mark. If it's not, like if it's the original drawing and it says, can you conclude that ABD is a right angle? Your answer is no. Just because it appears like it is does not mean you can assume it. It has to be marked, or it would have to say it in the directions somewhere. Questions on that? So again, the congruency mark's there, then you can assume the right angle mark there, then you can assume, but no other times.
Can we assume that a straight line is 180?
Yes, the straight line you can. That's the only one that you can without a measurement. All right, so here's the algebraic application of what we just did. It says use the diagram to solve for the indicated angle measurements. For A, God bless you, angle EFH. So what do I know about that diagram?
That EFG is 180?
This is a straight angle, so it's 180. So I would do 3x minus 6 plus 2x plus 16 equals 180. Combine my like terms. Subtract 10. 5x equals 170, which we now know. $34. And it wants you to find EFH, which is the one on the left. So I do 3 times 34 minus 6. 102 minus 6, which is 96 degrees. Questions on that one? All right, what do we know about the angle in diagram for B?
ABD is 90 degrees.
Good. That's marked as 90 degrees. So what can I do with those two angles?
Put them equal to 90.
Good. 2x plus x plus 9 equals 90. Combine my like terms again. 3x plus 9 equals 90. Subtract the 9. 3x equals 81. Divide by 3. And x is 27. Again, not done because this time it wants A, B, C, which is x plus 9. 27 plus 9, 36 degrees. So when a question like that appears in your homework, what are you going to make sure you do? Show me the work. Yeah. And read the directions, because if that's on the test and you get the X, like you don't want to get points wrong just from not reading directions. So make sure you're programming yourself to always read those instructions. All right, I said it before, but I'll say it again. Obviously you have 1/6 homework. I will publish the review if you want to start it, but you do not have to.